binomials, and we're going to multiply them. We've done this before. We did it on the day where we were doing function operations, where we had to multiply two functions together. So the first thing, I call it FOIL, which is first, outside, inside, last. Again, you may have heard of it as double distribution. You may have heard of it by using the box method. Whatever way works for you. Every single term is getting multiplied by the others. So 2x times x is going to give me 2x squared. 2x times negative 7 is going to give me negative 14x. So that's the first terms and the outside terms. Inside terms, 3 times x is 3x. And the last terms, 3 times negative 7 is negative 21. When you are multiplying binomials, you want to combine any like terms that you get at the very end. So be careful, because you can only combine x squareds with x squareds, x's with x's, numbers with numbers, and you're not going to actually add the exponents together. It's going to look exactly the same as what you are currently looking at. It's just you're combining the numbers in front. So this minus 14x and this 3x, the x's look the same, so I can combine those two things together. All you have to do is add the numbers at the very front of your term. So 2x squared doesn't have anything to combine with. What's negative 14 plus 3? Negative 11. And you just write x as is. Don't turn it into x squared. Don't do x anything with the exponents at all. It's just going to stay x, and then we're going to have minus 21. So this is the reverse of factoring. It's multiplying. Factoring is a form of division. Multiplying is a form of multiplication. So we always include number 2 because a lot of people want to make the mistake of seeing that exponent on the outside and they want to distribute it to both terms on the inside. And that's partially correct, but you're not going to get the full answer that you need. Anytime you have a binomial, so 2 terms and there's an exponent, that means that that binomial is getting multiplied that many times. So when you see this, you need to be thinking of the fact that the binomial is being repeated. If I only went in and distributed the squared to the 9x and to the 2, I would miss my middle term entirely, so it wouldn't be correct. So once I have it written out like this, I'm going to go in and follow the same steps. Double distribute, first times first, that's going to be 81. And x times x is always x squared. X times x is x cubed. That's my first term. Outside term, 9x times 2 is going to give me 18x. And then inside term, 9x times 2, 18x. And the last 2 times 2 is 4. So if I only went in and I made the mistake of just taking that squared and distributing it to the inside, I'd only end up with the 81x squared plus 4. But the correct answer is going to include the 18x's in the middle. So my final answer for this one should be 81x squared plus 36x plus 4. Now, I will kind of tell you this. We do not give you a calculator for this, meaning you have to know your multiplication tables. I can tell you, a lot of you know the process for doing most of this, and what messes you up is not simplifying your numbers correctly, not multiplying, dividing, adding, or subtracting correctly. So we will practice this. You will have kind of warm-ups and IXL assignments that kind of have you doing very simple things, like combining numbers together and listing factors and things like that, because a lot of you in Algebra 1 got really dependent on the calculator. And now that you're in advanced in high school, from here on out, you really don't get a calculator in geometry or pre-cal if you're in the advanced level classes. So we are trying to bring back that number skills, because you guys learned this in like 3rd grade. So you should know how to multiply and divide and add and subtract without a calculator. So multiplying binomials, perfect. Now, the next thing, first thing you should always check for when you are factoring is you always want to go in and see, is there a greatest common factor? No matter what, always check first. Sometimes there is one, sometimes there's not, but basically you want to look at these terms and you want to see, do they have anything in common? Because most likely, if you pull out that common factor, it's going to make your factoring go a lot smoother and it's going to be a lot easier. So the first thing you want to do is you want to see, do they have any numbers in common? And if I'm looking at example 3, I don't have any numbers in the very front of my terms. So I kind of go in and jump to the A term. So one thing I'm going to make a little note of, you always pull out the smallest exponent. So whenever I go in, for example 3, and I list the greatest common factor, I am going to look at variable A, and I'm going to look at the 2 that I have, and you always pick the smaller one. So in this case, they both have an A to the power of 2. So A to the power of 2 is a part of my greatest common factor. Then I look at the B's. If you don't see an exponent there, it always means that there's an exponent of 1. So if I'm looking at B to the power of 1 versus B to the power of 2, what's smaller, 1 or 2? 1. So that means B to the power of 1, which you can write the 1 if you want, you don't have to, is a part of my greatest common factor. Now, if the term does not have, so notice for the first term there is a C, and for the second term there isn't. If it's not both of them, it's not a part of the greatest common factor. So that means it's not going to be included. So in my greatest common factor, I'm not going to have a C because it's not in both terms. In order to be a greatest common factor, it has to be present in every single term you're looking at. So what we do when we find the greatest common factor, because it is a form of factoring, it's almost like you're doing division. And you don't have to write it this way every single time. Wyatt, close your computer. Thank you, all the way. So when I have a greatest common factor, I'm going to go in, and you don't have to write this every single time, but I'm going to go in and say I'm taking both terms and I'm dividing by that greatest common factor. So what we write as our final answer, we put the greatest common factor in the front, and you're going to have parentheses with whatever you get left over from your division. Do we all remember greatest common factor from Algebra 1? Okay, so just making sure, not completely new. If you have the same term, they basically kind of cancel each other out. So the A squared and the A squared kind of go away. The B and the B cancel each other out. But in that first term, I'm still left with a C. So that's what's going to be left over in my parentheses for term 1. For term 2, I do the exact same thing. A squared and A squared, they both are there. If you have 2 exponents and they're not the same exact number, you're going to go in and you're going to subtract them. So B to the power of 2 over B to the power of 1 leaves you with a single B. Now, I'm breaking this down as much as I possibly can. So I'm going to kind of explain to you why that became a single B. If you completely understand it, totally fine. But B to the power of 2 is 2 B's, B times B. B to the power of 1 is a single B. So you can only kind of take out 1 for 1. So that is why this goes away and I'm still left with the single B in the parentheses. So my final answer is A to the power of 2B with C minus B left over. Biggest mistake I see, because you will have questions like this on your test, is people will take out the greatest common factor, they'll write it correctly, they'll pull and see what's left over. You must write GCF at the front. If you do not include the GCF at the front, you have changed the problem. So if you are just factoring, which is all we're asking you to do for this test, because we're not solving or doing anything beyond that yet, you have to include the GCF in the beginning. Okay, let's jump to number 4. So we've gone full into detail for number 3. Number 4, we're going to take a little bit quicker. What do 12, 15, and 9 all have in common? 3. So I'm going to pull out a 3. If I look at the x's, you always want to take the smallest exponent. The smallest exponent is 2. So that means my GCF is 3x squared. So when I write my answer, there's going to be a 3x squared at the front, and I'm going to have parentheses with what would be left over when I go in and pull that 3x squared from everything. If it's helpful to you, you can always go in and write your GCF underneath each term so you can see that you're doing the simplification correctly. What is 12 divided by 3? 4. And then remember, you're subtracting the exponents from each other. So when I have x to the 5th over x to the 2, 5 minus 2 is going to leave me with x to the 3. What is 15 divided by 3? 5. And then I have x to the 3 over x to the 2. 3 minus 2 is 1. If you want to write x to the 1, you can. We don't require it for an exponent of 1, but we would not take off if you did have it on your test. And then I have 9 over 3, which is 3. And if you have the same exponent, they kind of cancel each other out. It really becomes x to the power of 0, which is just 1. But we don't ever really write that one. So in the end, factored form, pulled out my GCF. I'm left with 3x squared, 4x cubed, minus 5x plus 3. Yes.
Why is it not 3x?
Why is it what?
Why is it not 3x?
What happens when I have x times x over x times x? They all cancel each other out. X, 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 x. The x goes away. Technically, this is equal to 1. And 3 times 1 is 3. It equals to 1.
Ah. But then there's also the negative 5x.
There's no x.
Wait, would you take off
Say that one more time.
Would you take off points if we put an x in?
After the 3?
Yeah.
Yes, that's wrong. If you put x to the 0, maybe not, but if you put an x there, that is wrong. The x squared and the x squared cancel each other out. Yes, Leah? Because they're not completely canceled out. X cubed is x times x times x over x squared. That's x times x. So that only got rid of those. So there's 1x left over for the middle term. Yes, exponent rules. Okay, let's get to the factoring. Okay. I promise you, you need to pay attention. So, I have written out the rules for factoring that I think work best. Here again, I've said it before. If you know how to factor from previous teachers and you understand how to factor, you can factor. However you learned, I'm still going to teach it to you like you've never seen it before. So the first thing that you always do is you check if you have a GCF. And I will kind of talk about the steps as I do it, but I'm one of those teachers who think it's best to kind of see it as an example, and then we talk about the instructions. Do x squared, 5x, and 14 have anything in common? No. So in this case, there is no GCF. And so I'm going to go straight into the best way I have found over my 9 years of teaching this to factor. So usually what we'll do is we'll draw a big X. And then at the top, we have A times C, and at the bottom, we have B. If you do not remember standard form of a quadratic, that is y equals ax squared plus bx plus c. So whatever number is with the x squared term, that is a. Whatever number is with the x, that's b. And whatever number is by itself, that's the constant, that's c. So this is not something you have to identify every single time, but I'm going to at least come in and say from problem 5, A is equal to 1, B is equal to 5, and C is equal to negative 14. And I'm just pulling that from the question. So what is A times C?
A times C is -14.
Negative 14. Okay. What is B? 5. So what you're kind of doing in this process, and this is where the number sense is really, really important. I'm going to kind of write it out in words, but this is things you're going to do like in your brain when you're trying to factor this on your own. We want to know what multiplies to negative 14 and adds to 5. So we need to think of two numbers, and they can be positive, they can be negative. This case, they probably will have to be, that are going to multiply to be negative 14, and they're going to add to be 5. Any guesses?
-2 and 7.
You see how everyone else raised their hand, Max? Max, what did you say?
-2 and 7.
-2 and positive 7. I like -2. Positive 7. What's your question, Zite? No, it's add. You're adding them together. So Max told us -2 and positive 7. If I take -2 times 7, I get negative 14. If I take -2 plus 7, I get positive 5. It has to add to the bottom, multiply to the top. Now, here's where we're going to kind of talk steps. And some of your teachers may have shown you a shortcut. We'll talk about shortcuts. But I'm going to show you a method that is always going to work even when that A term is not equal to 1. So the first thing you do is we're going to take the two numbers that we just found, -2 and positive 7, and we're going to split that middle term. So what I mean is we're going to have x squared minus 2x plus 7x minus 14. Now before you, if I lost you, give me a second. -2 and positive 7 are coming from the two numbers that I chose that made this true. Are we all with me so far? They are x terms because the middle term was an x term. So all I did was split. And this method is called 4-term grouping. So that means I currently have 4 terms. So I'm going to start grouping things together. How many of you have heard of 4-term grouping? Couple of hands. Okay. So for 4-term grouping, I'm going to go in. I'm going to group the first 2 together, and I'm going to group the last 2 together. It's somewhat clicking again. First 2, last 2. Okay. What is the GCF of my first group? What do they both have in common? The x squared and the 2x. So I'm going to pull an x out. Okay, if I pull an x out, what am I left with? X minus 2. Perfect. Okay, ignore the first group now. Look at the second group, the 7x minus 14. What is the GCF for 7x minus 14? 7. Positive 7 or negative 7? Positive 7. I'll talk about the difference in a second. We'll do positive 7. And then what would I be left with?
X and -2.
X minus 2. Now, here is where the positive negative makes a difference. The goal of this whole process is that when you get to the point where you've pulled out your 2 GCFs, that the parentheses match. So notice that I have x minus 2 and I have x minus 2. If I had pulled out -7, they would not match. So your parentheses have to match. That parentheses is your first factor. Your first factor is x minus 2. Because if I distribute the 7 back out, I'm going to get 7x minus 14. I pulled out a GCF. Okay. We are getting there. The last factor, because there should be two factors. The second factor comes from the two GCFs you pulled out. X plus 7. That is our final answer.
We did the other part for that.
I have another one. Hold on. Zite, what's your question? Okay, hold on. Hold on. Okay. I will tell you, there is a shortcut for factoring when A is equal to 1. This will only work when A is equal to 1. And in Algebra 2, A is not always 1. A will sometimes be 2, it'll sometimes be 4, it'll sometimes be 5. And so in those cases, you have to do 4-term grouping. Now, I will tell you the shortcut. If and only if A is currently, which it is, equal to 1, do those factors that you pick, do they become your two factors in the end? Only when A is equal to 1. Will A be 1 for this class? No. So you have to know how to do this when A is not 1, which is why I showed you on an easy one before we go and do one of the harder ones. So A is 1. Okay, let's try it again. We're going to go through it again. Do I have a GCF? What is my GCF? 6. I'm going to pull 6 out. 6 is going to come out of the equation, and then I'm going to be left with z squared minus 5z plus what? Plus 6. Okay. Now that I have pulled out the GCF, this went from a problem where A was not equal to 1 to a problem where A is 1. You are focusing only on this part for now. And in this case, A is equal to 1, B is equal to -5, and C is equal to 6.
I thought you just said A was equal to 1.
And then I said we pulled out the GCF and we made A equal to 1.
Oh.
Okay, hold on. We'll get there. Let's practice first before we think of all the different scenarios that are not this scenario. Okay, top is A times C. Bottom is B. So what is A times C?
-6. Oh, positive 6.
Positive 6. And then I have B is -5, -2, -3. What is A? What is C? 1 times 6.
6.
Okay. Now, A is equal to 1. So can I use the shortcut? Yes. What is the shortcut? X minus 2, X minus 3. What is one of the notes that we put on the first page about GCF? We have to include it. So your final answer has to have a 6 at the very, very front. No, it does not. We will take both of them. Okay, let's look at number 7. Do I have a GCF? Do I have a GCF? Do I have a GCF? X. X is my GCF. So I'm going to pull an X out. I'm going to be left with X squared plus 2X minus 15. I want you to try to factor this on your own. Factor it on your own.
Wait.
Factor it on your own. I'm going to give you 2 minutes.
Guys, A is equal to 1. I need a lock. Why did I write -5?
All right, that's a test.
No, not right now.
No. If you are gonna take like all five.
Yeah. You need to put your GCF at the front.
What in the world does 2 give you? Like gives you?
I did it. Oh my god. It's negative. Oh my god. Mark, I did it.
Mhm.
Yes, I got it right. Wait.
What multiplies to negative 15 and adds to 2?
It's negative.
Good. Can you put the X at the very front?
Like, you can't be 15. Yeah, I did. There being no DCF.
Because they all have an X in. And this factoring method doesn't work when it's a cubed.
Okay.
That looks good.
I did it. No, I did it. Yeah.
Oh, you were first to come back. Oh,
Those don't add any.
Just check it.
I can't really see. Can I move up?
No.
The top multiplies to the negative 15.
They both add any. Okay. Yeah, that makes sense. I was trying to think of something that, like, I was trying to think of something that added. 5 and 3 do make 15.
Check your answer. Yes. Did you write -3 and then +5?
Yeah.
Can it be minus 3?
Yes, it can. The order does not have to be the same. It can be a different order. The numbers have to be the same, but you can write them in a different order.
I mean, the egg inside the other one.
I'm sorry, what did you?
It's never been exponent x on 3.
No, I only pulled out one greatest common factor. It goes at the very front. If you wrote x -3, x + 5, that is the same thing as what I have. Both of these would be fine. Both would be okay. Okay. These are all problems where a equals 1. Now we are going to do problems where a does not equal to 1. So, you should know how to do this from Algebra 1. That should not be new. Number 8. Do I have a GCF? No GCF. So, I'm going to go in and I'm going to identify A, B, and C. So this one, and we're going to make a note so that you can remember when you go back and look at this. A is equal to 2. I want you to say no shortcut. We are going to do 4-term grouping. So that means I'm going to go in and you approach this in the same exact way. We were doing that. But
Why do we not have a shortcut? Why does it say no shortcut?
someone answer Nala's question.
C equals 1.
Okay, what is A times C?
2.
2. What is B? 3. Okay, what multiplies to be 2 and adds to be 3? 2 and 1. So we are going to split the middle term. That means instead of having 3x, I'm going to write that as 2x plus 1x. So I'm taking the two numbers. This is literally what we did in the first example on this page. And I'm splitting that middle term into 2. So I'm going to end up with 2x squared. And the split is going to come from the numbers that you chose. So we chose 2x and we chose 1x. And then plus 1 stays the same from the problem.
Wait, what's the
It can just be x.
That's just the opposite of simplifying.
So we have to 4-term group in order to be able to factor. So that means we need to group the first 2 together and we need to group the second 2 together.
Oh.
I forgot. What do you do after this? Like, can't figure it out.
Okay, that's the answer.
Hold on. We are not done.
You gotta do it different.
Wyatt, what is our next step? Gabriel, what is our next step? You don't know because you're playing around.
What's it called? Interview.
No. What did we do after we grouped in this example?
I know.
What do we do, Christian? Greatest common factor. So, what is the greatest common factor in the first group? 2x. So, x plus 1 gets left over. What is the greatest common factor? And this one's kind of a trick question, but not really.
1.
1. Positive 1 or negative 1? So I'm going to write plus 1, and that's going to leave me with x plus 1. Remember, the big thing that I need you to think about once you're looking at that second grouping is you want the parentheses to match. They need to look the same. So yes, you could technically take out a negative 1, but your parentheses would not match at that point. So x plus 1, x plus 1. If they match, that is your first factor. My first factor is x plus 1. The second factor always comes from what were the two GCFs that you chose. We chose 2x and we chose positive 1. So that means my second factor is 2x plus 1. So this is a problem where the shortcut does not work. If you had used the shortcut on this problem, you would have said x plus 2, x plus 1. And that is not correct. So you have to use four-term grouping when it comes to a not equal to 1 problem. So group, GCF, and then you should have your factors at the end. So let's try it again. We're going to try it 2 more times, and then hopefully at that point it's stuck. Do I have a GCF for number 9? No. So no GCF.
Wait, couldn't 1 be a GCF? Wait, 1 does always be a GCF?
Yeah, but then it's not going to do anything. A equals 3, B equals 20, C equals negative 7. A times C at the top, B at the bottom. What is negative 7 times 3? Negative 21. My B is 20. Gabriel, what are my factors? No idea. You need to think about it. What multiplies to negative 21 and adds to positive 20? Max, what do you got?
Wait. Never mind.
Tom, what do you got? 21, negative 1.
Wait.
Does that work out? What's negative 1 times 21? Negative 21. What's 21 minus 1?
How is? Oh, I keep getting like.
Yes. It does not matter which order. Okay, so I'm going to go in. I'm going to split my middle term. I'm splitting it using negative 1 and 21. So we're going to have negative 1x plus 21x minus 7. Gabriel, what is my next step? We're back at the same spot of the same question I asked you. It sounds like we're going to have a quiz on factoring the next time I see you.
Wait, can you just get the quiz to Gabriel?
Grouping. What am I grouping, Gabriel? Grouping. What am I grouping together? The 3x squared and the 1x. The 21x and the 7. Try to finish this on your own. Try to finish it on your own.
I'm already confused and I just don't want to do this.
Yep.
Yay! This means that don't be quiet so I can know.
You know what's funny, Miss Martinez?
Would it be eggs?
What's funny?
I actually did like the first three by myself. That's kind of.
That?
Yeah, this one.
Yes.
My one question is what's the answer? What do I do after this?
Check for GCF for both groupings.
I have a question on this one. How'd you get plus one?
Because that's the GCF of the second grouping that we have. So since there's an X plus 1, if you can't see one that's like very obvious, you can always use positive 1 or negative 1. Yes.
Would it be -7 or just 7? Because it says 21 and -7, but
Well, you should have 21X.
But would it be -7?
It's in, like for this.
Huh?
Does it matter the order it's in for this?
No, but your GCFs may look different, but your factors should be the same at the end.
Okay.
Well, they don't look the same. This negative right here.
Then maybe you pulled out the wrong number.
No, we have the same number.
Think about it. Think about it. Yes. Hold on. That should be a -1. Just because in your work they don't match right now. So that should be 3x minus 1. And then your answer is correct in the end. Yes. Yeah. Did you pull out a -7 or a +7?
7. Positive.
So then that needs to be x plus 7.
-7 times -3 is 22. So 21 is.
Wait, miss.
Where's your x?
Oh.
It's not like 21.
Wait, is it negative?
Is it not
There's
negative
an
21?
X right here.
Not -21? No, because it needs to be positive 20. If I did -21 plus 1, it'd be -20.
Why is there an X?
The b is a positive number. Yes, Mark.
Everyone will have a quiz.
If you want to do it with the box method, you can. I don't know the box method. I didn't teach. I never learned the box method.
Wait, how'd you get
No X at the front.
Jack.
Close this for now. Okay, let's see. I saw a lot of people with the correct answer. So let's kind of walk through this really quick. If you did not get there, we need to stop talking. The longer you talk, the longer this takes, the less time you have. GCF of my first group is an X. 3x minus 1. GCF of my second group, this is where I said it's important to pay attention to, is it a positive or is it a negative? In this case, you should have pulled out a positive 7. And then we would have 3x minus 1. Your first factor comes from your parentheses. So 3x minus 1. Your second factor comes from your GCF, x plus 7.
But no.
Mm-hmm.
That should be almost filled up.
It's plus 7 because we have to have it match the parentheses of the first group. I went through it. Okay, we're moving on. I'll come help you later. Okay, let's do example 10. Okay, I will stop and I will give you your practice and you will have to do it on your own without any help from me. We need to finish this because you will have a test over this in like a week and a half. So, A is 12, B is -5, C is -3. If I do A times C and B, what's 12 times -3? -36. What is B? -5. So here is where you have to think of two numbers that multiply to be -36 and add to be -5. Liana, what do you got? -9, +4.
Same.
Go real fast.
It'd be so funny if one was
Try this one on your own.
Do you think no?
Try it on your own.
I promise Mark safe.
We go through like 7 auditions.
Stop talking, dude.
Yeah, Gabe.
You explain this. Why doesn't the one cancel out the one and there's no
What's 1 over 1?
one?
So a 1 has to stay there. Yes.
And nothing's negative there.
It's like that just makes okay. Because I just thought
Because what's 2x over 2x? No, it's 1.
I was trying to explain to her. She was like,
Come on, Christian. Try this last one. Number 10. What did you pull out from here?
I just pulled out 3 and 4 because that factors down. And it's multiply 4 times 3, it equals 12x. But
You need to pull out the greatest common factor. That's where.
I did it.
That's good.
No, is this good?
So this will be your first factor, 3x plus 1.
Okay.
This will be your second, 4x minus 3.
I'm so confused.
That's good. That looks good.
that's plus 1 because that is the greatest common factor.
Correct. Yep. Your ones look like 2s. I swear I glance at it every once in a while and I'm like, where'd she get a 2 from? There should be an X there. And then you're close. You're almost done. So what if I pull a 4x out? What has to go here?
Oh, wait, damn, I get it.
When Liana comes back.
This one's Inez. Okay. Ready? So it's this, right?
If I have 4x over 4x, what is that going to become? 1.
So, and that's what I have.
So then same thing of, that would be 1.
Negative 1 or positive 1?
If you're pulling out a negative and you wanted it to be negative, it has to be a, well, what's a negative and a negative?
Positive.
So it needs to be a positive 1.
So
So
then
now
it
your
would be-
parentheses match.
3x. Because I feel like, I don't know, something.
What is 4x over 4x? 1.
So no x.
No x. You're missing the GCF of the first group. Isn't just 4, it's 4x. Okay, let's see what we got. When I go in and group, I'm going to ask you to please stop talking so I can explain this, even though some of you got it already. Some of us may not have. So let's pay attention. What is my GCF of the first group? 3x? 4x. And so I should be left with 3x plus 1. I got a lot of questions as to why this is 1 and not x. If I have 4x over 4x, that is equal to 1. If I have 2 over 2, that is equal to 1. If you have the same number on top and the same number on bottom, it is not 0, it is 1. Next GCF is minus 3. 3x plus 1. First factor comes from your matching parentheses. So we have 3x plus 1. Second factor comes from your GCFs, 4x minus 3. Okay. Yes, Mark. It does not matter what order you put it in. Okay, let's go to the last page. If you wrote 4x minus 3 and 3x plus 1 in a different order, that is fine. The other answer that is acceptable.
I would 3x front of that though. Right now I got.
No, there's no 3x in the front. Okay, let's go to the back. These are formulas. The formulas. Gabriel, step outside. We will talk after this because I'm almost done. For the formulas that you get, you do not have to memorize these. You will be given these formulas on your test. The thing that you have to know is you have to know what your perfect squares are. Now, this is another thing where stuff that you've learned in 3rd grade, like way back, all the way into like 5th grade math, you talked about perfect squares. All of these numbers are a result of a number being multiplied by itself. So 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16.
Does it go back?
Does it what? Okay. So the reason why you have to know these is you have to be able to go backwards. Okay. Let's get started. So I will wait. I got all the time in the world. I don't have homework to do. Okay, so if I have x squared, that is the same thing as x times x. So my parentheses is a single x. If I have 25, what is 25 the same thing as? 5 times 5. So I'm going to put a 5 in this parentheses. So that means in this case, my A is x, my B is 5. All you're doing is figuring out what A and B is, and you're plugging it into the equation. So my answer, when I put this into factored form, is going to be x plus 5, x minus 5.
Wait, that's the final answer.
That's the final answer.
I don't even get it. Like,
Okay, what is, for number 12, I have a GCF. What is the GCF? 3. So I'm going to pull out a 3. That's going to leave me with x squared minus 9y to the 4th. So this one's a little different because I have 2 variables, but we still work on it the same exact way. I like to go in and I make 2 parentheses where I know I'm going to put something in those parentheses that's currently being squared. So we've already done x squared. We said that that's the same thing as x times x. So I know at least that A is equal to x. Now, when you do this for numbers and variables together, think of them separately and then kind of put that together. What would I have if it was just 9 by itself? 3, because 3 times 3 is 9. So one part of my parentheses is going to be 3. Now, just to kind of make this as a side note, y to the power of 4 can also be written as y to the power of 2 times y to the power of 2. So that is an exponent rule where the 2 exponents end up getting added together. Because I need to know what is getting multiplied by itself to make y to the power of 4. Because I'm trying to take it the same way where I looked at 25 and I saw that was 5 times 5. Looking at y to the power of 4, I need to think of that as y to the power of 2 times y to the power of 2. Because that is going to change my b term. So my b in this case is 3y squared. So once you know what a is and once you know what b is, all you're doing is plugging into the formula. So I'm going to have x plus 3y squared, x minus 3y squared. And then if you've taken out a GCF, the same note we made on the very first page of today was you cannot forget to include it in your final answer. So my final answer has to have a 3 at the very front. Okay, any questions on the difference of squares? It has to be subtraction. It cannot be addition. That formula only works for subtraction. Now, sum and difference of cubes. Second formula. If you look at the list that we give you, because we don't ever ask you for things outside of these numbers that we include on your paper. The highest we will go is 216, which is 6 cubed. Those are the only ones you have to know. We will never ask you anything other than those. So first one is an easy one. We're going to go in, and I do the same exact thing. This one doesn't have a GCF, so I'm just going to say no GCF. But I go in, I make my parentheses, and I try to see what number is getting multiplied by itself 3 times to make what I'm looking at. For x cubed, that's the same thing as x times x times x. So that means my a term in this case is x. For 1, if I have to multiply something times itself 3 times to make 1, the only number that works in that case is 1. So my b is 1. Once you've identified what a is and what b is, you can go in and look at the operation, because 4 cubes, it's going to make a difference. Look at the operation and see what formula you should be using. So we're looking at the bottom formula for example 13. I'm going to go in and I'm just going to take my a and my b that I have, and I'm going to plug it into the formula. Now, notice, for this particular problem, I kept it in parentheses. In the case of x and 1, it doesn't make a huge deal, because if you didn't, you probably still multiplied correctly. But if you don't have x or 1 by itself, you could potentially lose points if you don't actually square things and you don't actually multiply things. So the final answer is going to come from doing the squaring and doing the multiplying. You guys will have a new seating chart when I see you on Wednesday. We will have a new one. I told you we can have a new seating chart every day. Okay.
We're the only class with a seating chart.
Only class with a seating chart. Only one. Gabe is not the only problem. Okay. Really quickly, this is the last one. If I have to look at 8 and I have to multiply a number 3 times, what number is that?
4.
What's 4 times 4? Let's do it one time. 16, too big. Tyler, you got a question? Number 13? Because there's 2 formulas. Oh, like... Because it starts with a minus 1. The formula, if it's always the same sign first. Okay, what did we say 8 was? 2. Okay, the x is just an x, so my a is 2x. 27. What number times itself 3 times? 3 times.
That's times 3.
3. What's 3 times 3? 9. What's 9 times 3? 27. So my b is 3. So I'm going to go in. Yes, Luke. Oh, it's a plus. Thank you. It's a plus. So now, I'm going to go in. I'm going to plug into the first formula. So I'm going to have 2x plus 3. This is where the parentheses are going to matter, because you have to distribute that squared to both the 2 and the x. I'll get to it in a second. Minus 2x times 3 plus 3 squared. You will not get full credit on a question like this if you do not completely simplify. So the 2x plus 3, completely fine. For that first term, I need to take the 2 that I have as an exponent and I need to distribute it. It is okay to distribute in this case because we don't have addition or subtraction. So this will become 4x squared minus 6x. What's 3 squared? 9. There is your final answer. Okay, I'm going to come around. I'm going to give you your practices. You got 30 minutes. Technically, you probably should have enough time to do this. 12. Do not forget your 4.1 practice is due today. If it is not turned in today, it's late. Did you watch the video and fill in your notes? There is a video. I posted it in this class. Yes. Not unless you're in band, then it's due next class period. Give me a second. One, two, three.
The three.
I'll come right back around home. Let me pass these out. We are not moving out of our seats. You are staying in your assigned seat. Yes, go ahead.
When you're done testing them out, you come back and help me with something on the.
Yes. 1, 2, 3, 4.
Yeah.